Let me start my AI assistant is working. Shame we can't give it a name. All right. So what I'm going to do, so I won't be here next week. There won't be a Tuesday meeting next week because I'll still be recovering from my knee replacement surgery. I'll be back the week after. What I'm going to do tonight is I'm going to go over the code for weeks 3 and 4. So you'll see that, and then we'll spend a little bit of time designing a database from scratch to see how that works. But
Sounds good.
before we, do you have any questions from this week's assignment? Any comments, thoughts?
No, it's all good.
Alrighty. Now let me share my screen. Okay, and let me pull up this. Okay, so we're gonna pick up with the code. We're gonna be talking a lot more about. We're gonna talk a little bit more about how the where clause works. We're gonna repeat some of the stuff from last week, and then next week, week 4 is where we talk about joins. So a lot of this stuff from week 3 I've already talked about, and it's usually designed that way because week 3 is when I designed the database for the first time. So I'll go through these pretty quickly. If you have any questions, stop me and let me know. So here we're running the from the film table, we're selecting title and length. And in my where clause, I've got where length is greater than 100. So these are pretty um, self-explanatory. This one here, I've got set title, length, and rental rate from film where length is greater than 100 and rental rate is less than 5. So here I've got my and clause, which means both of these need to be true. They're coming off of 2 different columns, and they've got one is greater than 100, one is less than 5. So run that. If I change that to or, it means either of them have to be true. So it actually returns everything. And here we've got more of the likes. So when we do the greater than, less thans, or the equals, those are more definitive values. Here, when we do the likes, this is a text-based thing. So this means, again, from last week, show me the film title where the title starts with an A. This one is shows me the title is like it starts with an A, it's got a second letter, it has a third letter's an A, it has a fourth letter, and the fifth letter's an E, and I don't care what's left at the end.
The case sensitive.
No, they're not case sensitive. um, so let me qualify that. By default, it's not case sensitive, but there are ways to set up a database where it is case sensitive, and then it has to do with you'd have to do it on purpose. It's not within the in MySQL you can't do, but other ones you can. It's what's it called? When you define the database, you set the structure of it, and you can say if it's case sensitive or it's symbol sensitive or whatever it is. There's a bunch of different ones.
But
But
not in my.
MySQL is not case sensitive. No, MySQL is a very um, if Microsoft SQL Server and Oracle are the older siblings that are in college, MySQL is the middle schooler. It's pretty smart, but it doesn't do what the other ones do. There's a lot of it's learning as it goes along. There are some commands that we'll talk about later in the semester that don't even work in MySQL. So here again, so we got where it's like capital A, whatever letter, E, anything after that. If I run these two, I get that one there, and then I get this here. So this is anything that begins with an A, and these are the only two that have A, whatever, E.
You ran them both together and you have different tabs for the results. I
Yeah, that's
didn't.
in MySQL. What happens when you run multiple tabs? They give you when you run multiple queries, it gives you separate tabs. That's a very unique feature to MySQL. Usually, if you do it in anything else, it just gives you the results one top of the other. So that's kind of cool that they do it that way. Now we're using non-equality again here. Everything that has an equality has a non-equality. So like This has a non inequality. So this is not like. So show me anything that doesn't start with the. Show me anything that doesn't have a length of 100. Okay. So this is the first one. This nothing, it doesn't start with the. It's just whatever. It doesn't have the word, the three letters the in front of it. And then over here, this is where length is greater than.
Can you do a not equal? Um,
So not this is not equal.
mhm.
This is also not equal.
Right. Can you do it both ways?
Yes. So the caveat to that is with this one, if you're in anything other than MySQL, this only works for text-based queries. So MySQL allows this to be either text or numeric, but in Microsoft SQL Server and Oracle, this only works for text-based. Same thing's true with this. In MySQL, it works for both. In SQL Server and Oracle, this only works for numeric. So if you did this with the not equal, returns the same result.
Do databases often, or is it possible to upgrade from a MySQL to SQL Server or Oracle or something?
You cannot upgrade because they're completely different products. So you
Yeah.
okay. So what you'd have to do is
You could take, it's like all text though, you can recreate or whatever, just like in a notepad and just copy it over, right?
actually whenever you install something like Microsoft SQL Server or Oracle, there's always a tool that comes with it to consume other databases.
And so you could
Yeah.
essentially.
I mean, you
Cool.
could export it out to a CSV and import it that way, but the faster way, because when you look at a database, you have multiple tables with connections and stuff. So to try to get that out to a flat file and import it into another system is complicated. Whereas if you just in like Microsoft SQL Server or an Oracle, you just install the product and then point it to the other database, it'll pull everything. It'll pull in the tables, the indexes, the connections, the column rules, and everything. It's just easier to do it that way. Um, if you want to play with that, you can download Microsoft SQL Server for free. You go and find something called Microsoft SQL Server 2024 Developer, no, 2022 Developer, and install on your machine. And then you can just use the tools in there to import the database. Great questions tonight, though. Thank you. Um, keep them coming. Uh, so here I've got length between. That's another one between 50 and 100. So it just gives me the. So if length was actually a choice here, it would show me the length of it, but it would be between those two numbers.
Can you do value between or something like that?
What do you mean?
Can you just say where, oh, I guess it's length, never mind.
Yeah, yeah.
Length is a field.
When you're doing between, it has to be two numbers. I
Yeah.
don't think I've never tried alphabetical things. I don't think it works. It's really weird to kind of say that anyway because I can show everything between A and F. I guess it would.
You can do dates though.
Yeah, you can do dates. You can do money.
Yeah.
Anything numeric, you're going to show up there. Yeah. Um, one of the things we talk about, we're going to talk about initially here is putting in subqueries. A subquery is whenever you have another query in parentheses that takes the place of value. So in here, I've got where the length is equal to the length of the film Academy Dinosaur. Now, why would you do this instead of just having the number, which I think is 100? Um, this is just a simplistic way of showing this. So this is a static query because these numbers don't ever change, right? This is a dynamic query because if instead of so if instead of that I did rental rate, right? Because the length will never change. But if I change that to rental rate of Academy Dinosaur, right? If the price of Academy Dinosaur changes, oh, it'd be helpful if I did this. Um, this query will change along with it, right? So
Hmm.
yeah, so we try not to have static queries whenever possible. We want the queries queries to be as dynamic as possible because we want to be able to change. I mean, stored procedures and everything come kind of into that later because then with stored procedures you can add variables and people can have input into these, but that's beyond the scope of the class. But in this case, if you use a subquery in some capacity, then you have a dynamic query. And here's the same thing where length is this just I just got a little fancier here with the title with the like. So any subquery you can put in there. You can I think last week someone asked the question how many subqueries can you put into a query? Um I looked it
Yeah.
up and it used to be like 14 was the most you could do before like the engines like said no that's too much. My rule of thumb is usually like 3 at the most. Because I don't know if I explained about execution plans. So what happened when you run this query? I told y'all that when you run this query runs first. It runs the from first, then the where, the from first, then the select, then the where, and then the order buys and stuff like that, right? And then it runs the rest of this. So what happens in the background of this? It creates something called in Microsoft SQL Server called an execution plan, and in Oracle it's called an explain plan. I think it's called an explain plan in MySQL because MySQL is essentially Oracle Junior. So whenever this query runs, it will go back and find that execution plan and run and not it won't reprocess the query. It will just get the execution plan and run the execution again. Whenever you run a query for the first time, it it processes the query into machine language, makes the execution plan, and then runs it. So the first time you run a query, it always takes a little bit longer than the other times. When you run it, the second time you run it, if you're still in the same window here and you haven't shut down, it just goes and grabs that execution plan that you used before and reruns it so it doesn't process everything again. And so, as you can imagine, that execution plan can get mightily complicated with too many queries. So you want to keep that as simple as possible. It's a good rule just to keep queries as simple as possible. I've seen things that people have written that are like 1,000 lines of code in a SQL query, and it's really unnecessary. Um, it's a term I've coined the term sedimentary code because like sedimentary rock is just the new rock falls on top of it and it keeps layering up and layering up over time. When you get into some businesses, there'll be code that's been around for 15, 20 years, and rather than fix the code, they just add to the bottom of it. So you'll see like dates and times of people at the bottom for like 15 years just adding code to make it work, and it just makes it worse and worse and worse. And it gets to the point like where you just can't fix it anymore, and no one wants to rewrite it.
Can you just real quick, you were saying order of execution. I was noting that and the PowerPoint said it was from where group by having then select then order by. Did I get that right?
Where? Yeah, from where? Yeah. It does from, and then I got it backwards there a second. 'Cause it does from first because it pulls all the table into memory.
Yeah.
Then it does the where clause and the group by because where and group by are the same things. Um, and then I haven't gotten to group by yet. That must be this must be the week 4 code because group
Because
is very specific.
yeah.
Because when you do what, so it does the where clause, so it filters it on on the rows, and then it filters it on the columns, and then the select. So it's from where group by select order by.
Having comes to after group by and before select, it
Ha-
said that.
Having is a version of where for aggregate functions. So from where and so where and having are the same kind of filtering clause. Group
Yeah.
by is a special case. I think it's over. I think we get over here when I talk about group by. I don't. Where's my group by stuff? Is it next week? So group by is like this. So why haven't I done it? Okay, so group by is like if I did select film, the title. Here, give me title, and give me rental rates. And give me I think I'm missing code. What's wrong with my code here? I usually get into group by well in before this here. Give me a sec. Let me figure this stuff. Wow. Okay. Oh my. Oh. Oh. Why did I get that last week? Oh, I skipped last week. I am so sorry. Here. Okay. I should have talked about that. Okay. So here we've got.
I
I,
think you did talk about it.
did I? Okay. I forgot.
Yeah.
Oh, I usually go into this for so because I reiterate this many, many times. So here I've got select rating and count star from film, group by rating, order by rating. So these are aggregates. That is, I'm taking numeric values and grouping them together. There's count, there's sum, there's average, there's max, there's min. So they're aggregate mathematical functions. The group by is a specific clause for aggregates. So whenever you're using an aggregate in a query, you must have the group by because it tells you what columns are not being aggregated. So if I ran it without this, it's going to should throw an error. Yeah, it throws an error. Let me get this out of the way here. Yeah, aggregate query without a group by because it needs to know that it's aggregating this column by this column. So any column that is not in an aggregate needs to be in the group by. So now when I run this, I know that there are 178 G-rated movies, 193, 223, 96. So here we've got rating by average length with the group by again, and the same thing. A G-rated movie averaged about 111 minutes. And here's replacement cost max and min based on rating. Okay. But that's where group by comes in. So it's not a where clause, but it's a very specific clause that has to do with aggregates.
Yeah, I understand.
Yeah.
It's where you can filter by the result of those for after they've been grouped. I understand.
Right. Yeah. Yeah. It's just basically saying this is not an aggregate. This you're aggregating these columns by this column.
Yeah, and you could sum the rental cost and then
Yep.
do anything over a certain
That's
amount
that's
and
big
stuff
stuff.
like that.
Yeah. You can do sum and everything. Yeah. So yeah. So yeah,
Yeah.
we're talking about this more and more as we go on and do more queries. There's also other things that you can do with them, but yeah. Aggregates are a pretty significant part of coding. And every semester, I've got at least a half dozen people who write an aggregate like this and forget the group by. So that's why I say it like 17 times in one lesson. So, all right, thanks for bringing that up. I don't remember talking about last week, but if you said I did, I believe you.
I think so.
I don't
Yeah.
trust my memory sometimes. So that's cool. Okay, so now we're going to talk about joints. This is the week 4 stuff, so we're going to flash forward ahead to next week. So when because of the way we design databases, we make sure when we're talking about this in a minute when we design a database. Um, when we create a table, we make sure that only information that is pertinent to the title of that table is in there. So if I were doing a database about books, I'd have a book table, and in there would be the title of the book, the amount of pages. I wouldn't put the author in that book table because more than one author could write a book, so I need a separate table for that. But I'd have all these columns that would deal with what's ever in that one title, whatever the book table is about. So the book, if I'd have an author table, I'd have a publisher table, I'd have a genre table, I'd have anything else like that, right? So because all the information is spanning across multiple tables. To get the information that I need to write a query that pulls from multiple tables. Even in here, I have film title here, but I don't have what actors are in it. So we have to join these tables together. And the most fundamental join and the most, I think it's the most ridiculous join, honestly, is we've got unions. So what a union join does, it just takes the results from one query and tags it to the results of another query and puts them together in one result. So here I've got select first name, last name from actor, and select first name, last name for customer, order by last name. I run that, and it just gives me all the results.
And you think that you use that the most?
I don't
The
use that ever.
bold?
We never use
Oh
that.
yeah.
No.
I've used it before, but not for stuff like this.
I've written SQL code for like 22 years, and I've never used Union.
I I've I've worked with Microsoft Access databases for about as long,
Yeah.
and I would use union queries for very few things, but it's a unique thing. Yeah.
Yeah,
I was surprised when I thought you said you use them a lot. I'm like, what?
the only time I've ever actually used them was if I was, so let's say I ran a bookstore, right? And you ran a bookstore, and we joined our bookstores into one bookstore, but we had two different customer tables.
Hmm.
So we'd run a union against our two customer tables to see where there was overlap.
Yeah.
So we would
In
make,
a real life application, like for my business, it would be like I have customers that have one type of service and I have customers that have another type of service. And sometimes there's crossover where they have both, but not always. So
right,
if I'm wanting to, match up and make sure I get a full value of how much I'm paying for a particular customer, I might have to run a union to pull
exactly.
both services together.
And is this your second database class?
Uh, it's my second database class of UI. Yes.
Okay. So yeah, so and what I found is with these unions for something like that, you can write a join that gives you more dynamic information and fills in the blanks, but we can that's a whole different thing. But the thing that gets me about unions, and this is where you can sometimes get a little sidetracked, and this always got it for me. The problem I have with them is it just cares that there are two columns. Uh, oh, 'cause I didn't. Oh, I should have done the last.
It puts them in two different columns, not the same column.
Yeah, so here, so if I put actor ID instead of first name and I run this query, let me get rid of these where clauses.
Yeah, then you can have first name and actor ID in the same column, then you have to line it up.
Yeah, so as long as there's two columns, it doesn't check.
Yeah.
So it's a rookie mistake. People don't really make it. And the union all versus the union. Um, so here, if I run the union all with Davis, I get four results because it gives me where there's duplicates. If I run union, it doesn't give me duplicates.
Say that again?
So right now I ran union, right? I ran actor where last name is Davis and customer last name is Davis, and I ran it and it gave me two results. If I do union all, it's going to give me the duplicates.
Oh, that's cool.
Yeah.
That's nice that it'll take out your duplicates.
Yeah. So and that's a handy little thing. Like I said, this is just a fast and dirty way of joining two tables to get fast results, to essentially it's to dedupe um tables.
Yeah, I used to have to, like in Access, it didn't do that. It would give you all of it all the time, and then I'd have to run a group by on the result of that query in order to get out the duplicates.
Yep,
So,
yep, yep, exactly. So here, so this will be the last one we do here for this query. There's not a lot of code work in weeks 3 and 4 because I spend a lot more time designing databases because this is where we start talking about final projects. So here I've got select for last name, title rating from actor, interjoining film actor on actor ID. So you'll notice a couple of things here. I've got this letter here. So what I'm doing is I'm aliasing the tables so I don't have to type out their name every time I use them. Because when I have when I have the same column name in the tables I'm joining, and I don't identify what specifically one it is, I'm going to get an error saying, uh, what's the word? Vague column ID or something like that. So here I've got last name from the actors table, the title from the film table, and the rating from the film table. I'm joining actor to film actors because if you look at film, I don't have any actors in here. And if I go to actor, I don't have film in there. So I got a table that connects the two of them. And all it has is actor and film in there. And then I'm joining it to film, which is the same thing on film ID from the film to film actor table. And when I run that, it gives me my nice little join. When I do so joins, if we remember back to second grade in Venn diagrams, right? So I've got where's my book there? I got this table and I got this table, and then I got actually let me change that to yellow, and then I can do that to orange. So that looks good. So here is I got table A, I got table B. Okay. So if I do an inner join, and this is let's call it C. If I do an inner join between tables A and B, the result is C. It shows me where the information is the same between both of them or whatever column I join it on. So in the case of film and film actors, it was the film ID. So wherever film ID exists in both of them, that's the results I get. So I've got inner joins, I've got left outer joins, and I've got right outer joins. Okay. So that's my inner join. If I do a left outer join, if I say a left outer join B, what that's telling me is I'm going to take all the results from A and all the results from A here, right? And the result. Now I'm forgetting how these work.
And just the stuff in B where
That
they
matches.
have an equal value of ID.
What's going to happen? I'll just show you. My brain's. I'm focused on the search in a couple of days. That's where I'm thinking right now. So let me get this. Let me just show you what I'm talking about. That's not it. Here we are. Get a little ahead of the game here. What you got here? Okay. So if I've got select last name is actor, last name is customer from actor, inner join customer on last name, order by last name. So it just shows me where they match, right? If I do a left join, actor is on the left, customer is on the right. If I run this, I get this. It shows me everything that's an actor and puts nulls where it's not in customer. So that's how I know it's not there. So it gives me everything in actor and just where customer matches. If I run the right join, it does the opposite.
Mhm.
Now, in everything else in the world, there's called a full outer join. That start working here? No, no, it didn't work.
You don't have to use the word outer, just
Yeah,
full.
just full join. Yeah, right here. It hasn't worked in MySQL. Yeah, no, it still doesn't work. So if you do this in if you do this in like MySQL,
Hmm. This is MySQL.
I'm sorry, in sorry. Okay. If you do this in Microsoft SQL Server, I'm gonna get rid of this here and I put the union here. This is what a full outer join looks like. It gives me the results of the left and the right all together into one.
So I'm gonna see nulls on both sides.
Yeah. So you get down here to the other side, and then it'll just start showing this up on the other side. That doesn't match.
Yeah.
So full doesn't work in MySQL. It works everywhere else, but that's what right and left.
Union does the same thing then.
Yeah, union is the same thing. It eventually it's going to work here because this command here. Um, so for a long time, except didn't work. So here, so if I do this inner join here, it's going to show me all this stuff here, right? And then here I've got it's like last name, title, rating from actor, inner joining, film actor, where the rating is NC-17, and I get these results. I get
So it's except using would we call that a subquery then? It looks like another query.
it's sort of a subgroup. It's so you see it's in the same place union goes.
Mm-hmm.
So where union joins them together, except eliminates these results from this result. So here in this one, I have
Just essentially, it is running two queries
yeah,
and
but they're
grouping them
not
together.
but they're not subqueries because
Hmm.
they don't exist within each other. They're two separate
Right.
queries run together
Okay.
with an exception.
Hmm.
So
Yeah.
here, the first query gave me 562 rows returned. The second gave me 1128. So if I run this together, it's going to give me the difference between the two.
Hmm.
So, and you'll see no NC-17s here.
Hmm.
Okay. So, and the reason I bring this one up is because this is a question on your test, but this didn't work in MySQL until about a year and a half ago. They just added,
Wow. Great.
they're trying to catch it up. So, so yeah.
Was it Postgres? SQL, is that used a lot, or what would you say
Yes.
is the most common use?
See, what's the most common use is I don't know if there is a most common use because it depends on the application you're using and the company you're in. So like um if you're in a company that has like giant databases and data lakes and massive amounts of data, you're probably running on Oracle.
Okay.
If you're running on a company that has a bunch of little databases and supporting multiple applications, you're probably running Microsoft SQL Server because
Is it
Hmm?
is it basically the same code though, just slightly different syntax or more
It's slightly different.
words?
It's slightly different syntax. There's slightly different functionality, and there's
Okay.
definitely different costs
But overall, it's got very similar functionality.
because everyone uses Transact SQL. Everything's made in tables. Everything has indexes. Everything
Yeah.
has queries and stuff like that. But there's
Mhm.
like it's I kind of compare it to like German. Like if you go to Germany, there everyone speaks German, but there are like 20 different dialects. So not everything means the same thing everywhere else, right?
Yeah.
Like in MySQL, you can do this and use double quotes and not have a problem. If you do that in SQL Server Oracle, it fails because it doesn't like double quotes.
So
But yeah,
single quotes in database code is preferred just because it's more universal.
yeah, yeah,
Okay.
yeah. And that's just one of those coding things that are there. And so when you get used to it here, when you get used to it other places, and they let you double quote other places, it just no one ever uses it. So but so Postgres is generally used by companies that don't want to pay for licenses because Postgres in some aspects is free. Um,
Is
and
MySQL used a lot too? Or-
MySQL is used a lot as well, but mostly for like much smaller environments. Like if you host a database, if you put up like a e-commerce site on your own on one of those platforms, they'll give you a MySQL database on the back end.
Nice.
So it depends on the scope of your operation because there's Oracle, there's Microsoft SQL Server, there's Postgres, there's MongoDB, there's Cassandra, there's MySQL, there's
But
and
MongoDB is not relational, so you're
no,
getting into the non-relational too.
right, but people use MongoDB as well in place
Yeah.
of their support, and then a lot of companies actually have proprietary databases uh,
Really?
that build their own database, and you can't use them anywhere else. There's an application. Uh, there was it was an application a long time ago that we
Like
had.
Salesforce or something?
Like
Or
Salesforce is one. Microsoft Teams is another.
oh,
Yeah, someone actually used Microsoft Teams for the week two assignment for reverse engineering a database, and I'm like, what they said was absolutely correct, but um, Teams uses a proprietary database built in Azure that you can't
okay.
queries. The most fun is when you have a company that develops a database with their application that uses a standard platform. But when you look at it, the tables are called like A1, A2, A3. And
That's super fun.
yeah, and I'm like, I don't know how their developers do it, but I've dealt with databases like that, and you have to go in there and try to, and like the columns don't have like name, they're like all numbers.
Yeah.
They must have a way to look at it. So it's
You have code to decrypt the code to
yeah,
get the correct one.
the proprietary nature of databases is really, and I don't know why they're so freakish about it because it's a database, nothing spectacular. But I've dealt with applications that build their own backends like Salesforce, and they have proprietary backends that you can't get into. Um,
Yeah.
even Oracle has their own products that have proprietary backends. Like there's a
Mm-hmm.
Oracle has a product called Oracle Audit Vault that
Mm-hmm.
pulls data into it, and it's a proprietary database, and you can't take anything out of it unless you know the sneaky tricks. So yeah. All right. So that is weeks 3 and 4 in code. So what I'm gonna do now is I want to talk about designing a database. Have you ever designed a database from scratch, Dina?
Yes.
Okay. So then we will do this for the people who are never going to watch this.
Maybe they will. They're gonna struggle and they're gonna come and watch.
So generally speaking, so like I've got 37 people in the class. Um, there will be 1 to 4 people who show up on a weekly basis, and then maybe 10 who watch the videos on a regular basis. Because I even get when I put I put I put things like the one thing I can always tell how the semester's going to go is I tell people how to get the textbook. Because if you go to the site to get the textbook, it doesn't work. You got to follow the specific instructions.
Yeah.
And I put it in an announcement, and I put it in a spread. I put it in an email.
Mm-hmm.
I talked about it in the first video, and then
And then
very
you get 50 people still emailing you and texting you and saying, I don't know how to do it.
yep,
Yeah.
yep. So, and then people ask about late work, and I get it's a lot, and I don't get mad about it, but it's
I
just
think I asked about late work. It's one of those things where we've got all these classes and everybody's got different policies and it gets confusing.
I really and I've never been talked to about it, but they've always looked at me funny when I say I let week work go until week 10 because the first semester I started teaching this class back in 2018. And that first semester, I had a student who was in Nicaragua who
Hmm.
emailed me and said, "Hey," and this is not a lie. He's like, "Hey, the rebels are invading my village. I'm under a table right now. I'm not going to turn my work in this week." And I'm like, "Dude, stay safe. We'll deal with it." Every semester, I've got someone who's lost a member of the family, someone who has a baby, someone who gets married. COVID was fun. Um,
Yeah.
so I don't see a point in being
Then you
fact.
have to deal with people's excuses in personal life and all of that, and just like manage yourself and get it done. That's the
And
point.
I ask that you let me know that things are going on. Like if you're going, like having surgery, or if someone in your family has passed away, or something's happened, just let me know, and I work with them.
Yeah.
And probably there's always two people, and it's always just two people in the class who on week 10 turn in the entire semester's worth of work. So that's always fun. And I thought about changing that, but all it means, I don't want to punish the entire class for the
Mm.
always two people. So
The anomaly.
yeah, so I'm once in week 10, I'm pretty much a stickler about that. And like if you turn a week 10 late, it doesn't count.
Mm.
But I feel that's pretty fair. So let us create a database. New model. So I've just gotten back into baseball cards. So I'm going to create a database for a baseball card collection, I think. So I think the first, and I think I said this before, when I used to teach class in person, I had a classroom that was whiteboards all the way around.
Hmm.
And I would start in one corner and design
Yeah.
backgrounds. And that's how I prefer to do it, but this works too. So my first table is going to be player. And well-designed databases, the table is always in the singular. So I'm going to have name, the player ID. And then so we'll do a little my little side conversation about data types. Choosing a data type is incredibly important because this defines what the table is going to be for the rest of its life. Um,
Hmm.
in this, there's so when we look at um, we've got tiny int, we've got small int, we've got int, we've got medium int. Is it big int? Let's see. Let me cheat. Medium int, and then there's big int. So big int, medium int, tiny int, small int. Okay, so that's where I was going to get my. You,
And then you have other number things.
yeah, I'm just gonna buy ints right now. So there's medium int, and then there's big int.
Hmm.
Now, tiny int is negative 256, positive 256. Small int is somewhere around, I want to say,
I mean, it ranges from
yeah,
the negative all the way up to the positive.
yeah. So I figure small int is somewhere like 25,000 negative. These are just rough numbers.
It was in the book in the reading.
Yeah, 5,000. And the reason why this is important is, when you're choosing a data type for the column, you've got to look and say what is that, what biggest number is that ever going to be? If
Yeah.
I'm doing a column for age, I'm probably
Hmm.
not going to choose int because int is like 2 million.
Big. Yeah.
Yeah, and big int is gigantic. So it's important to decide this because in the story I tell with this is the first company I ever worked for as a DBA had a table that was created about 5 years before I started working there, and they chose um, int as the ID column value for that table, and int is negative 2.5 billion to positive 2.5 billion, or roughly thereabouts, or 25 million. And when they designed the table for the company, they never thought they'd reach over 2 million entries. So go to me working there, they're at like 1.9 million entries. And they're
That's
close.
a hard thing to change.
It is hard. It's easy to change. It just takes a really long time because you're
Yeah.
literally doubling the size of the,
Has to.
yeah. So we had to take the database offline for two
And
days.
then doesn't it? mm, Okay.
Yeah. So what you do is you just basically write the code to change the column. And this what I would have done is I would have created a new table and dumped all the data in there, which would have gone faster. But
Oh yeah.
because the people who created the database had done it in such a way that the index structure was so ridiculous that
But then
creating,
you can't do an auto number either, though. If you're creating a new one, you have
well,
to.
you can use that in it was in SQL Server, so use a column called identity. And once it's done, you turn identity on, it picks up where it left off.
Oh, okay.
Um, so that's a little different that they do in SQL in MySQL. But still,
Mm.
because we had to just upgrade the column in that existing table, it went row by agonizing row or R bar and increased the size of every row one at a time because that's how it had to do it. That's how databases work. So it was 1.95 million rows when we made the change, and it took 2 days and doubled the size of the table. So it was a bit of a mess. So it's important. That's just the Cliff's Notes version of why it's important to choose this correctly. So I'm gonna put this down to uh, little int or small int because I don't need tiny int, and I definitely don't need. I'm not gonna have that many small. And then I'm gonna have. If I spelled it right, it'd be even better. Small. When you use the drop down, it puts the parentheses at the end of it, and it doesn't like the parentheses. So you gotta type small int. I'll do first name. I'll do last name. And I think for player, I also need to know team. I'll need to know uh, for years played, year played.
Would you use year for that?
I would probably use date for this.
I know that the year, what, it only went
Oh, you.
back as far as 1905 and went as recently, or
Oh,
it
that's right.
goes to 21 something.
You can do year. Year doesn't exist in other systems. Year exists.
I thought it was kind of silly that it was so limited to the range.
Yeah. Well, that is.
That's because it makes it a tiny int or whatever.
Yeah. Yeah. And
It's
the
usually the
it
same.
actually goes back to early versions of T-SQL where no one realized the year 2000 was coming.
Mm-hmm.
So, and they didn't realize like, oh wait, we have 1901 and 2001, and things are going to get confused. And then we'll go. Uh, what else we want? It's birth date, birthday, and then
Is char a thing or just varchar?
so great question. Let me talk about that. Let me change that to date, time, or just to date. There we are. So char and varchar are essentially the same thing with one specific difference. So if I do,
Well, char is a set, like it has no flexibility to it. Like I could do char two for state and it has to have two characters in it, right?
well, it does no, it
But I
does.
didn't.
It's not that it has to have two characters in it. Is it can only have up to two characters in it. But no
Mhm,
matter what you put in it, it's going to take the space of two characters.
mhm.
So if I did like if I was doing last name and I did char 45, right? And I put in the last name Joe, right? It's going to take a 45 character space, even though there's only three.
Mhm.
If I do varchar,
It's dynamic.
yes, it's dynamic. So it will take up to 45. And if
I
I
didn't think it liked it when I used a char for a state, a two-digit state. And I don't know why. I don't know.
it's a lot of people do that because it's only two letters.
Yeah, I didn't think that the system allowed me to do it, is what I meant.
Oh no, it will. It will. What happens is
Okay.
the only you have to if you do a char two for a state, whenever you have the way to input the data into the database, you've got to limit it so your end user doesn't type out Florida instead of FL and get the error.
Hmm.
So, but yeah, so you can do whatever you want here. You can char one, you know, if
Okay.
But it's like it gets it has to do with how you input the data at that point in time to prevent errors.
Mm-hmm.
So we got birthday, team, years playing. Let's put position. So let's look at that. So let's start here. Okay. So now,
Position could change though, right?
well, team can change, position can change,
Mm.
playing can change. So that's where we get down to. So whenever I design databases, I just kind of pick a table to start with and just start laying out what I want to know about that table. And then I'm like, okay, so player ID, absolute first name, last name, absolutely team. Team can change over time. And the way you figure it out is like one player can play on many different teams, and one team has many different players. So you end up in a money minute relationship.
Mm-hmm.
A new table called uh, team. And here we'll have team ID. I'm actually going to make this a tiny int because there's only like 36 teams right now. And then we'll do team name. And then team location and team stadium name. And then we'll do occupancy of stadium.
Which would be probably another
Yeah,
entity.
yeah, you're getting it.
Yeah.
You're with me here. Okay, so right now I've got my team and I've got that. So here I'm gonna. So what I can do here is I can go here and into here and I can delete the team column. And I can go down here and this is my many to many um, relationship. And I can go here and it creates my many to many.
Mm-hmm.
So now you'll see here, ID player, I've got one little key there because that's my primary key. And I've got one little key here, that's my primary key. Now here in this table, I've got two columns that are my primary key.
Mm-hmm.
As long as this never repeats, that
Mm-hmm.
can remain the primary key. However, for this table, it is possible. Well, I'm going to add a couple columns here on this
Might
table.
need to get a year or something,
Start
whatnot.
ending year.
And
Actually, here.
then add a primary key.
Right. So I need to
One of
add.
those has to be part of the primary key also. So,
Well, what I'm actually going to do with this table, because a player can come back to a team,
mm-hmm.
I'm going to change this. I'm going to make a team ID column. I'm
Do
going
you
to.
find that's better than using a natural ID of three fields?
You could do that too. I think sometimes the index can get a little jammed up if you have three
Yeah.
columns in the field.
Uh-huh.
So it again, it's
Because
dealer's
then you have the duplication in other places where you have to.
exactly. So I'm going to do.
Can you still keep it unique though of those three items together?
So if you have a team player ID like this, right,
Mm-hmm.
and you make it part of the primary key. So now I've got
Yeah.
three in the primary key here, right?
Right.
So move that up here. And I go here and I take these guys off of the primary key.
Right.
If I leave these three here, and this one is automatically numbered, then this will always be unique because I've got the table ID.
Well, if I mean, let's say somebody's doing data entry and putting it in, and they put the same player's starting year in there twice, for that transfer or whatever.
Right.
Unless you make it unique, you have to have something that identifies that the team, the player, and the starting date, right, are unique
Uh-huh.
together. then you can still have duplication.
Well, what we
So
yeah, so
how can you do that?
so we'd have to do that as a check in the insert query rather than I don't want to
You can't manage it on the back end then.
I mean, I suppose you could do this and jump it to four columns in there,
Oh,
everything be the primary key. I think that gets a little bulky. Maybe just have
yeah,
four as it in there. That way it doesn't.
yeah.
You
That's
can't
the only way to do it, though. I just wasn't sure
you
if
can,
there was another way to say, hey,
you
unique between these three.
so you can make that unique right there, like that. You make team ID player to start year unique and do a different index. You can do
Can you?
yep, right here. See, just
Because won't that make it so that somebody else can't start the same year?
no, because it's the so I have so here I've got the primary
Yeah, if they're a primary key, that's true. But
right.
if they're not, it
So
wouldn't.
here I've got team ID, player ID, and starting year is unique. So those three have to be unique.
So that doesn't mean just that that's a unique starting year.
It just means
Um,
those three items together have to be unique.
I
So if
I
I've
would think that that meant that the starting year can't exist for anyone else the way you have it written right now.
no, it's the way it is here. These three have to be unique because it's the same thing. Those three have to be unique together. It's the same thing here. These three have to be unique. So
I
I,
understand when it's a primary key, but when it's not part of the primary key, didn't you just tell it that the starting year cannot occur for more than one person?
no, because the team player, the team ID, and the starting year have to be the same. These three have to be unique together. When you see it right now, let me
So that column means unique together.
yeah, let me show you. Um, okay, so when it does it by default, so you'd probably have to write. Okay, so when you do the automatic build, primary key. Please write this. There's your primary key here. So you probably have to write it. Okay, so we're gonna have to do this instead. It's been a hot minute since I've done this. Let me put a pin in this and get back and make sure. But there is a way to make sure that these are the. There is a way to write way to write the index, the unique clause to make sure these three together are unique. And I will get back to you on that.
Without doing it in a primary key. So my experience has always been I had to make it a primary, all three of them, a primary key in order to make sure that they're unique together. Otherwise, you're just saying like, hey, maybe it's only one person can have the pink car, of the cars on the lot. I only have one pink car. You know what I mean? It's
Yeah.
just like
No, I know what you're saying, but I
the
know.
way I know how to do that is you have to make it that starting year part of the primary key.
Yeah,
And you don't actually need the team player ID when you do that. So
and
that would be the only way to
uh,
keep it smaller.
that is a really good point. Um, yeah, so that's I hadn't thought about that. So if I do these three, then that's my primary
Yeah.
key. Oh yeah, that's good.
Yep.
Yeah. That's way better. Yeah, because I know there's a way to write an index or a it's not an index, it's a constraint. There's a way to
Yeah.
write a constraint on a table that says these columns must be unique together, and it's not a primary.
That's what I'd like to know. I would be interested in that because the way you have it right now is the only way I've ever been able to do it.
Yeah. So I will get that information back to you because I know there's a way to do it because I've done it in the past.
Okay, great.
So and I
I
it might be something that's only done in like the bigger boys, like the Oracles and the Microsoft SQL servers. But I will
maybe
to you.
All
So,
right.
but you have a great idea there. And one of the reasons why I like doing this with the class is because then we can collaborate on things and you can catch things that I miss because I've been doing this forever, but you still forget things, right? So here,
Hmm.
team player starting year, and that's a great primary key because those will always be unique. Ending year will change. I'm gonna add a column over to my player table to retired, and it'll be a
Unless they come back and make a
yeah. And we
sportsmanship comeback, which is, I did learn too that, it has to be reminded to me every once in a while. You don't want to always, it's not always worth building in the exceptions everywhere, those things that are super rare. Could they happen? Yes. Is it likely? No. It depends on what kind of scale of a project you're working on and how important that is.
I think if we did this and I had a retire thing, if they came back, I would just uncheck the box and like put a
Yeah.
history that they retired. So yeah, so
Yeah, that's good.
yeah, so you got they got the players team starting year, and then here, like we said, position. We need to make another table called position, and get a position ID, and we'll make that a tiny int, and then position name, and then because one player can play multiple positions, we're going to actually make the join to
From
that,
many to many.
and then we're going to actually. Nope,
Not a many to many?
I hit the wrong button.
Oh,
I grabbed the wrong because I moved this thing up in my many to many move with it. So there's my many to many. So this can go many to many here, but I'm also going to do yeah the team because I want to know what team. Now the problem when you're doing it in this, it gives you all the other things here, and I don't care about that's the primary key, so it's got to be there. So the player, I want to know what position they played on the team. So, but then we're gonna
each time.
yeah.
Each, yeah.
So yeah, so we're gonna leave that. So probably we'll probably play with this primary key because
It's kind of messy.
yeah, it's gonna be messy. Plus, if they come back, if they like leave one team and then come back and play a different position,
I probably would just create a different player. I probably wouldn't make that connection. I'd probably just have you find it through the trail of tables. Why make the connection there? You can go back and trace it through the player because you already have a way to get to it, right?
we disconnected it here. How would we know
Yeah,
what team the player was on when he played that position? What if like Bob only was a pitcher on the Marlins and he was like a first baseman everywhere else?
right.
So we'd
Because
have, yeah.
you're looking about time frame right now. So where you have position has player, just give it a date. Just add a date field to when they had that position
Hmm.
in that table. And then you can do all of your filtering and your dynamics based on date.
But that might work. So if I did date here,
Yeah, because then you can build any query you need. Is like, okay, well, I'm looking at a specific year or date for this team and who are the players and positions. You can go through the players table and come to the position as player.
that's one way to do it. I've never done baseball table before, so this is new for me. So I think we could do that. That might work. We'll do a start date, end date.
I just meant like inside that same
I'm,
table.
I keep trying to put it in that table, but it's pointing to the wrong table.
Yeah.
So give me this table, please. There we go. Okay, so start date and date. I'm going to think about this a little bit because I think that's definitely a way to do it.
I know that if I ever needed to find the information on a particular date, I could come and say, well, what date are you talking about? And
Yeah,
if you have start dates, that player was this player between this date and this date. And, You know, the team has players.
Yeah, I can see where you're coming with. I can see where you're coming from with that. It's it's not resonating with me, so I want to think about this a little more.
Yeah.
Do this a different way, and there's definitely one of the ways to do it. I think because you can corroborate the dates by whatever date they played this position, and corroborate with the dates here, and the team has the player.
Yeah. That
Um,
way, if it's like, hey, who are the players on this team on this date?
yeah,
You can go and find it with just this information that you have, and it keeps too much redundancy from happening.
yeah.
You know where to find the information.
Yeah. Oh no, yeah. And again, this is me. This is a brand new. I've never designed anything like this before, so my brain is going in 1,000 different directions. So I'm trying to figure out what to do this because, yeah, I think that's probably the best way. But I'm gonna be stuck on this for like a day or two now because I'm gonna play with it.
You're like, I want to do this now.
Yeah, now I want to do this.
I've
I used to.
I've actually designed lots of databases using like all these like low end tools, like database tools. Like it's only Microsoft Access, right? So
Yeah,
it doesn't have so like your many to many stuff I had to do manually, you
yeah.
know,
Yeah.
just because
Oh, this and when I started doing this, this didn't exist. I was in SQL 2000
yeah.
manuals.
No, it doesn't exist in Access either. So
Yeah, yeah. Well,
I had to hand write everything and you know,
the
anyway.
only access I've ever done was making a front end for a SQL database. I've never done
No, I used it to do all kinds of crazy stuff.
yeah,
So
access.
queries on queries that literally did take overnight to run whole payroll things for 2,000 sales reps and stuff like that. It was crazy. But it was only access.
I'm gonna have to think about this because well, this will be good while I'm recovering from my surgery. I'll think about this. So yeah, so it's we're at timer almost 10 minutes over. So yeah, so you get you know this, and for anyone who's watching, whenever you do this, whenever you start seeing things that shouldn't be in the like position shouldn't be here anymore, you take this column out of
Right.
here. That gets removed. Um, in team stadium shouldn't be there because one team might have many different stadiums, and one team might also have many different locations. And this is actually vague enough. It could be any kind of sports card at this point. It doesn't have to be baseball. But yeah, so location would be different. Stadium we'd have a different and stadium occupancy definitely wouldn't be here. So we'd have to create a locations table and a stadium table and put that occupancy in the stadium table because football teams and baseball teams change locations all the time. I mean, the Utah Jazz used to be in St. and used to be in New Orleans.
You know, you could do team has players and do a many to many with position, not position has players, but just position.
Mm-hmm.
You could do a many to many there.
Oh, that's an idea too.
Hmm.
The only trick would be what if one player no, they don't generally play two positions at the same time. So it'd be just, oh, that might work. There you go. That's good. Oh, there
I'd
you go.
probably just leave it like you've got it though and keep it simple.
Yeah. I'll play with I will play with this and
I don't know that you'd have a purpose to create another one. Like what's the unique information or benefit of it?
mm, yeah. Yeah.
Unless that, you know, some teams have different positions than other teams, but I don't think that's how baseball works.
Well, actually, it used to be not, but not anymore because the American League used to have designated hitter and nationally didn't. And I think they both
Even if you had that, I don't know that you need to track it because
no,
it's just like
whatever position that person played because designated the person who's designated
it'll come through.
yeah,
Yeah.
it's always different playing a different position too. Okay, so I'll have to think about that, and then we get the stats and everything. But anyway, that you get the idea. So it's been fun designing days with you, Gina. That's been fun. Uh, I don't really want to get another.
I like databases too.
I know,
So
it's so much fun. So
if
I'm
I could do what you do later in life, that would be great.
well. I tell you, if you have the experience, if you got that much access experience as you get close to graduation, um, get used to one of the bigger boys like SQL or Oracle, and
Yeah.
and then you can move into those. So
Yeah,
And
I'm taking this class. This is not a required class in my degree. I'm taking this class so I can take a more advanced
Mhm.
database class as my elective.
Cool.
So, yeah,
When classes said keep my contact information, and if I can help you find a job, I will.
I'd love that. Thank you.
Okay. So we're gonna call it a day here.
Sounds
I'll
good.
grab this and everything. So thank you for your input today. It's been fantastic talking to you.
You too. Take care.
Good time. Bye.
Bye.